Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P2413 indicates an issue with the exhaust gas recirculation EGR system in the Honda Civic models from 2011 to 2015. The EGR system plays a critical role in reducing nitrogen oxide emissions by recirculating a portion of the engine's exhaust back into the combustion chamber. This process not only decreases emissions, but also helps to improve engine efficiency. The components associated with this DTC typically include the EGR valve, the EGR valve position sensor, and the powertrain control module, PCM. The EGR valve is located on the intake manifold and may be connected to various sensors and wiring harnesses. When this code is triggered, it can greatly affect engine performance and emissions, requiring timely diagnosis and repair. The DTC P2413 signals that there is a malfunction within the EGR system. This usually involves the EGR valve, which is responsible for managing the recirculation of exhaust gases to reduce emissions. The valve works in conjunction with the EGR valve position sensor, which reports the position of the valve to the PCM. When the EGR operates properly, it can lower combustion temperatures and reduce harmful nitrogen oxides. However, if there's a malfunction, such as a stuck valve or faulty sensor, it may lead to increased emissions and a decrease in engine efficiency. The physical location of the EGR valve is typically found mounted on the intake manifold, along with its associated wiring and sensors. When diagnosing the DTC P2413, various potential causes must be considered. A faulty EGR valve can prevent the proper recirculation of gases, leading to a malfunction signal. Damaged wiring, particularly to the EGR valve or its sensors, can disrupt communication and operation within the system. A defective PCM may also cause incorrect readings from the EGR system, leading to a false error code. Poor connections or loose terminals can contribute to these faults, necessitating a thorough visual inspection. Each of these components plays a significant role, making it imperative to check not just the EGR valve, but also the surrounding wiring and the engine management system. The presence of DTC P2413 can lead to several noticeable symptoms that may alert the driver to potential engine issues. One common symptom is a rough engine idle, indicating that the air-fuel mixture is not being properly regulated due to malfunction in the EGR system. Additionally, reduced engine performance may be experienced, particularly under load or acceleration, as the system may not be efficiently managing exhaust gases. Increased emissions can also result from a malfunctioning EGR system, failing to meet environmental regulations. As such, it is essential to diagnose this code promptly to avoid further damage and ensure compliance with emission standards. The first step in troubleshooting DTC P2413 involves verification of the problem. Begin by turning the ignition switch to the on position or pressing the engine start-stop button to ensure the vehicle electronics are active. Once in the on position, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This step is crucial for resetting the system and ensuring accurate diagnostics moving forward. After clearing the DTC, start the engine and hold the RPM at 3000 without load until the radiator fan activates. This process helps to simulate operating conditions so that you can perform a test on the EGR system. After performing these steps, check the results of the EGR test in the inspection menu of the HDS. Depending on whether the result is OK or NG, you will proceed to the next relevant step. Following the initial check, the next troubleshooting step requires turning the ignition switch off to the lock position. This ensures that all systems are completely powered down before proceeding. After that, turn the ignition back to the on position to activate the electronic systems once more. The next critical action involves checking the EGR valve position sensor via the HDS. This sensor is denoted as EGR VLS in the data list. You need to ascertain whether the voltage reading is approximately 0 volts. If it shows about 0 volts, you will move to the next step in the diagnostics. However, if the voltage indicates otherwise, this may require additional troubleshooting and possibly a deeper investigation into the EGR system wiring and connections. In this troubleshooting step, begin again by turning the ignition to the lock position. Next, disconnect the EGR valve 5P connector, ensuring it is safely separated from the main vehicle wiring. Once disconnected, turn the ignition back to the on position. With the EGR valve connector unplugged, measure the voltage between the specified test points using a multimeter. The test condition is critical here, as the ignition must be in the on position. The test points require checking the VCC2 line at the EGR valve connector to determine if approximately 5.0 volts is present. If this voltage is observed, proceed to the next step. If it is absent, other issues within the circuit may need to be resolved before continuing. The next step involves ensuring that there are no breaks in the wiring for the VCC2 line. Begin by turning the ignition to the lock position to avoid any electrical mishaps. Then, use the HDS to jump the SCS line, which places the system into a diagnostic mode. Proceed by disconnecting the PCM connector B, which is essential to isolate the electronics for accurate testing. Once you have done this, check for continuity between the designated test points, ensuring that there is a continuous connection between the points specified for the VCC2 wire. This continuity check will help determine if there are any open circuits that need to be addressed before further diagnosis can continue. Continuing with the diagnostics, you must focus on the EGR-L wire, which connects the EGR valve and the PCM. Again, turn the ignition to the lock position for safety. Following that, jump the SCS line as previously noted, placing the electrical system in diagnostic mode. Disconnect the PCM connector C to isolate the components effectively. Check for continuity between the specified test points, particularly focusing on the EGR-L wire. If continuity is found, it suggests that there are no shorts in the wire, allowing you to continue to the next troubleshooting steps without issue. If continuity is absent, this indicates a short in the wiring that requires repair before proceeding. In this step, focus again on the EGR-L wire line. By checking for continuity between the test points specified, you will once again ensure that there are no interruptions in the wiring. Conduct this check only with the ignition in the lock or off position to ensure electrical safety. If continuity is confirmed, there are no issues in the wiring, and you can proceed to the following test. However, if continuity is not indicated, this suggests an open circuit in the EGR-L wiring, requiring meticulous examination and repair of the wire between the PCM and the EGR valve to restore proper connectivity. This troubleshooting step focuses on the internal circuit of the EGR valve position sensor. To do this, turn the ignition to the lock position and ensure the EGR valve 5P connector is disconnected. Next, at the EGR valve side, measure the resistance between the specified test points. The condition for testing requires that the ignition is off to ensure accurate measurements. The key objective is to determine whether the resistance is at least 100 kiloohms. If the reading meets or exceeds this threshold, this typically indicates that the internal circuit is functioning correctly. If not, replacing the EGR valve is the next course of action to rectify the problem. In this consecutive measure, you will once again focus on the EGR valve position sensor by measuring the resistance between two specified test points. Ensure that the EGR valve 5P connector remains disconnected, as well as the PCM connector C. The ignition should also be kept in the off position to avoid erroneous readings. The aim is to determine whether the resistance is 100 kiloohms or greater. If the reading indicates this level of resistance, it typically suggests that the EGR valve is functioning correctly. However, if the resistance is below this value, it reinforces the need to replace the EGR valve due to internal faults. At this point in the diagnostics, checking the EGR line becomes crucial. Begin by measuring the continuity between the determined test points while keeping both the EGR valve and the PCM connectors disconnected. This continuity check will help ascertain whether there is a short circuit in the EGR wire connecting the EGR valve and the PCM. If continuity is present, a short exists, necessitating repair of the EGR wire before advancing to further diagnostic steps. If there is no continuity, it suggests that the EGR wire is not shorted, and you should then move on to the next troubleshooting stage. This step involves another continuity check for the EGR line. With the ignition set to lock or off mode, conduct a continuity test between specific test points. The objective here is to ensure that there are no breaks in the EGR wiring between the PCM and the EGR valve. If continuity exists, this indicates that the wiring for the EGR is intact, allowing you to proceed with further diagnostic efforts. Conversely, if continuity is absent, it confirms an open circuit that needs to be repaired to ensure signal integrity between the components. As you move to the final continuity check, you will assess the PG line between the EGR valve and body ground. Ensure that the ignition is turned to the lock position to maintain safety. This test will involve checking for continuity between the designated test points to determine whether the PG wire is functioning as it should. If continuity is found, it affirms that this wiring is in good condition. If there is no continuity, this indicates an open in the PG wire, signaling the need for repair to ensure proper ground connectivity for the EGR system. The 12th step involves reconnecting the PCM connectors B and C to restore communication in the system. At this point, you will perform a practical operation test of the EGR valve. To do this, connect terminals at the EGR valve to the battery positive and negative terminals using jumper wires. Start the engine and let it idle, observing how the engine behaves as the EGR valve is energized. The aim is to see if the engine stalls or runs roughly. If it does, it indicates that the EGR flow is functioning as intended. If the engine appears stable throughout this test, further investigation into EGR functionality may be necessary. In the final troubleshooting step, it is essential to perform a visual inspection of the EGR ports and passage. Turn the ignition to the lock position and remove the EGR valve for access. Clean both the intake manifold EGR port and inside the valve itself using throttle plate cleaner to remove any carbon buildup or blockages that may inhibit flow. After performing this service, reinstall the EGR valve and reconnect all necessary wiring. Finally, turn the ignition to the on position and reset the PCM using the HDS, followed by conducting the EGR test to confirm functionality. If the test results are not satisfactory, it may indicate that replacing the EGR valve is necessary to resolve the issues causing the DTC. After completing all necessary repairs based on your diagnostic procedures, it is crucial to verify that the repair was successful. This involves performing a final diagnostic test using the HDS to confirm that no DTCs are present and that the EGR system operates correctly under various conditions. It is essential to check for any recurrent symptoms that indicate the problem persists. If the DTC P2413 is cleared and does not return after verification, you can confirm that the issue has been resolved. Careful attention to detail during these final stages is critical to ensure the reliability of your repairs and the optimal operation of the Honda Civic. Preventive maintenance is essential in ensuring that the EGR system functions effectively over the lifespan of the Honda Civic. Regularly inspect the EGR system to identify any potential issues early on. This includes checking connections and wiring for signs of wear, corrosion, or loose terminals that can lead to faults like DTC P2413. Additionally, cleaning the intake ports periodically can help prevent carbon buildup that may obstruct flow and affect performance. Keeping on top of these preventive measures can greatly extend the lifespan of the EGR system and enhance overall vehicle efficiency, ultimately saving costs in repairs in the long run. In summary, understanding the EGR system's crucial role in emissions control is vital when dealing with DTC P2413. A structured approach to troubleshooting, beginning with problem verification to comprehensive checks on the EGR valve, wiring, and PCM, can lead to effective resolution. The steps outlined provide a detailed roadmap to not only address existing issues, but also ensure that future problems are mitigated through preventive maintenance. By implementing these strategies, you can enhance the performance of your Honda Civic while adhering to emission regulations and prolonging the vehicle's reliability. Please like and subscribe to the channel. See you next time.